Hi there, my name is Maeve, and this is a quick demo of a rendering experiment that I put together a little while ago called RayGBA. It's a simple ray tracing renderer that runs on the Gameboy Advance, written in C++. RayGBA supports 4 types of shapes: spheres, triangles, disks, and cylinders. Each shape gets a material with shading options for ambient, diffuse, and specular colors, as well as reflectivity, and can receive light from directional and point lights. The program contains a collection of scenes to demonstrate its various features. When a scene is selected, it uses each pixel's screen position to generate a ray that extends into the scene. It checks each of the shapes in the scene to see if the ray intersects with it, picks the closest intersection, and uses the scene's lights and the shape's material to determine the pixel's color, as well as casting new rays into the scene to detect shadows and calculate reflections. The first thing you'll probably notice is how slow it is. I knew it would be slow from the start, since the GBA really isn't built for this. The graphics features of the GBA are meant for sprites, tiled backgrounds, and bitmaps. A few games get away with a kind of 3D by changing sprites' transformation matrices in between each line of the screen being rendered, but Raytrace 3D is just way beyond anything the GBA could do in a reasonable amount of time. But if you're willing to wait, the GBA can render ray-traced 3D scenes. To be more practical, I mostly use an emulator to fast forward the rendering when I'm demoing or debugging it, since I can't be bothered to wait that long every time I need to retry the render. By far the most difficult part of this project was getting the underlying math working. Since I had built versions of a ray tracer before, I already knew the algebra for finding the intersection of a ray with the various shapes, and the control logic for generating and shading all the rays. But the GBA presented a unique challenge in its lack of a floating point module. Floating point numbers are the only way of representing fractional numbers in most modern systems and programming languages, and the GBA's ARM processor is just old enough that it doesn't include circuitry for performing math with floats. That means that if I used floats in my code, the compiler would fall back on much slower software implementations of those operations that would make rendering take even longer. To get around that limitation, I wrote a fixed-point math library with a custom struct called fixed32. Internally, a fixed32 is just a 32-bit integer, but it overrides all the math operations with functions that treat it as a fixed-point number, with 16 bits for the integer part and 16 for the fractional part. The major advantage here is that addition, subtraction, and equality checks can be performed very quickly by just treating it as a regular integer, and other operations that do require additional math are still much simpler and faster than a floating point implementation. I also wrote a similar vector type that's just a bundle of 3 fixed 32s with operator overloads and vector functions like calculating the dot product or magnitude. This project originated as a bit of a combination of 2 different classes that I took during my undergrad at Georgia Tech. The first of those was the computer graphics class, which had a big mid-semester project of creating a simple ray tracer. I really enjoyed that project and the class as a whole, and eventually ended up becoming a TA for that class and doing some of the grading for the same project in a later semester. The other class was Media Device Architecture, which sounds a bit dense but was actually a class entirely focused on making games and software for the Game Boy Advance as a way of learning low-level computing. This also ended up being one of my favorite classes, as I found myself investing way more time and energy into my projects than I needed to because I was just having so much fun with them. After I graduated, I spent a fair bit of my free time experimenting with the GBA and eventually had the idea to try making a version of that ray tracing project to run on it, and the result is the program you're seeing on your screen now. The scenes it's rendering are the exact test cases from the graphics class, and it has all the shapes and material options from the original project as well. I've been considering picking this project back up, and I have a few ideas about what I might add to it. I may add some optimization features like bounding boxes and bounding box hierarchies. Currently, if you render a scene with 20 tiny spheres in it, every single pixel gets tested against every single sphere, which gets expensive fast. Bounding boxes would allow it to skip the more expensive operations in many cases and enable better performance on larger scenes. I also want to add more material options like transparency and refraction, since those could be doable without generating too many more rays. As a long shot, I'd kind of like to try making the scenes editable at runtime, but the complexity of making an editor would be a huge time investment that probably isn't feasible right now. Just to prove to you that it really works, here's RayGBA running on my actual Game Boy Advance. Thanks so much for watching. If you want to take a closer look at this project and its source code, there's a link to the GitHub repo in the video description.